Hi. It is said that compound interest is the most powerful thing in the universe, the most powerful force. Unfortunately for us, the inflation in economic terms is, well, it operates on the principles of compound interest. It can be said as it is a negative compound interest. And this is the reason why, at the one hand, we are screwed, and at the other hand, why it is so hard to understand, to visualize the actual impact of the inflation. Because, well, right now, since in Poland we have the record-breaking numbers of 20% inflation, now we can finally start to realize the problem, but still not very the scope of the problem, because of this very unintuitive, non-linear behavior of the inflation systems. Well, inflation systems can be described with great accuracy with the differential equations. However, differential equations require pretty advanced mathematics that requires a bit of studying. What I want to show in this episode is very simple approach to the differential equations by applying the programming computations, because differential equations can be solved, so to speak, in the brute force instead of solving the actual equations. Of course, it won't be as accurate, however, it will be a very quick, very easy way to do so. And because of that, I think it would be interesting, and such modeling of inflation can give us a quick answer to how to think about it, how to perceive it. Because, when there are charts, when there's something happening visually, we can usually better understand it. So, lecimy z tematem. Before we continue, a quick disclaimer. This model was created and should be used only for educational purposes. It is not meant to be used as any sort of a tool for financial decision planning. It is way too simple, way too inaccurate, and operates on the data that is simply not precisely enough measured. It is just to learn how differential systems behave, to depict this behavior and see some patterns for educational purposes only. Okay, let us define the environment and actor in this environment. The actor is a personification of a person in our model, in our environment. The actor lives or dies in the environment, makes decisions according to the parameters of the environment, and tries to live or even thrive in the environment. Our actor has two sources of income. It has salary, because he or she works, earns money through work, and our actor also may have an ownership in 0, 1 or many apartments. Now, let us assume that our actor, as soon as it buys the apartment, already, instantly, he or she will have a client to rent this apartment. So we can assume that buying an estate automatically generates passive income. Now, some may ask why apartments, why not anything else? To be honest, I've chosen the apartments because investment in apartments is rather simple, due to the fact that on our beautiful Earth we have a constrained area and population only grows. It is safe to assume that urban area will be more and more scarce, so it seems like a good investment in houses, and it requires a little less knowledge, a little less financial knowledge than investing in the companies, in the stocks. So these are our sources of income. The actor works and may or may not have apartment. Our actor also have costs of living, housing, food, medical details, and so on. So our actor earns money and spends money. So we have a sort of a symmetry in our system. There's a potential for accumulation of wealth, and there's also a potential for losing all that wealth. So let us add one more rule. It is the retirement rule. Our actor does not want to work all his or her life. It wants to, at some moment, retire and live from the earnings, and perhaps, if he or she gets some houses, live from the rent from those houses. So we have two states in our environment. There's a state of active worker and there's a state of a pensioner. Pensioner does not earn salary, it only has accumulated money and it has ownership in houses. Now, of course, part of our taxes goes for pension, for elderly. However, I purposefully did not use that in computations because it is getting more and more complicated on actually figuring out how much it will provide money. So we have the environment, we have the actor, so it is time for a strategy. Strategy is the behavior of the actor. It is a formulation on what environmental conditions an actor performs what action. Let us assume that our strategy is very, very simple. On each epoch, actor checks how much money he or she has, and if that amount of money is enough to buy at least one home, he or she will buy it automatically. Just like that. No worrying about the future. If our actor has money for the house, our actor will spend money for the house. Okay, so we have the environment, we have the actor, we have a strategy, we have a set of strategies of cardinality of 1. That's okay. It is time for listing the parameters of our model. So first of all, we have the inflations. Inflations are inflation of cost of living. So it is a measurement of how much the cost of living will rise with each epoch. We have inflation of salary. It translates to how much the salary will rise with each epoch. There's also the inflation of apartments cost and the inflation of the income from the apartment, which translates to what is the increase in the amount of money got from the apartment with each epoch. By epoch, I mean in this particular example, a year. We will be using our model with a granularity of 1 year. Then there are initial conditions like amount of money on the start, amount of apartments, amount of salary earned with each epoch, and income from apartments. And there's also years of work before retirement. So this last parameter will depict after how many epochs there will be a transition from the environmental state of active worker to the state of the pensioner. Now, in each epoch, we will be computing the values in this epoch. Since it is a differential equations, so we have not only the current value, but we also have a rate of change. It is depicted here. It is a very simple recurrent form, which translates to the amount in the next epoch is the result of multiplying the value in current epoch with 1 plus rate of change. For example, apartment cost in the next epoch is equal to the apartment cost in current epoch multiplied by 1 plus yearly apartment inflation. Let's assume that yearly apartment inflation is 2%, so it will be multiplication by 1.02. Now, the inflation may be constant or may also change over time. This is why it is denounced by the T letter here. So, let us start with the scenario of no inflation. So, we have 80 years of simulation. Initial money is 0. We have no money initially. Initial apartment cost is $65,000. It is around the average in Poland right now. It varies from the city to city, but we can assume that it is $65,000. There's apartment inflation of 0. I wish we have an apartment inflation of 0, but no. Initial apartments owned 0. Initial cost of living is $7,836 per year. It is around the Polish average right now. Cost of living inflation in this particular scenario is 0%. Initial earnings is $9,144 per year. Once again, it is average Polish income in a year, around. The inflation of earnings rise is also 0. Initial apartment earnings is $2,604 per year, an average for Poland. Apartment earnings rise, the inflation of apartment earnings is 0% and years of work is 50. And what can we see? There is no inflation, there is no deflation. So apartment cost of living, earnings from one apartment, it's all frozen. It is a constant value. So because of that, because these values are constant and earnings outweigh the cost of living, we have the accumulation of wealth as long as the person works. Later, there is a sudden drop in the amount of money. It is because the person finally, after around 50 years, our actor finally earned enough money to buy one apartment, and that one apartment generated some money, but unfortunately it wasn't enough to combat with a lack of steady income due to retiring. So unfortunately it seems like even with no inflation, it is simply not enough time of earning money due to the salary to own enough apartments to stay alive during the retirement. It is a pretty grim, but hey, let us now simulate the other option. The option is marriage. So initial earnings is doubled because we assume that both spouses work, and initial cost of living are not doubled but are multiplied by 1.5. It is because living for two persons is usually cheaper than living alone due to buying in bulk, due to warming of a house, and so on. So our pair of actors, they are virtually one actor. They have been aggregated into the being of one actor, actually is able to buy more and more apartments, and by doing so, this new actor is able to retire. As you can see, the accumulated wealth is a signal of a lot of variance. It is because our actor, as soon as he or she, now it is they, as soon as they earn enough money to buy the apartment, they buy an apartment. So this is why it goes up and down. Basically, they does not accumulate any money for them. They just take money and do something with it. And because of that, as you can see, the apartments owned signal is rising exponentially. And because they had enough earnings in those early stages, they could afford houses that later financed another houses, which financed another houses, and so on. So they broke away from the poverty due to better ratio of money to spending. Now let us see how our pair of actors, which are aggregated to one virtual actor, will behave in the environment when there's a cost of living inflation 2%, the same with earnings rise 2%. It is a typical inflation of 2% in the normal times, but there is a problem in the apartments market. Apartments inflation is 5% and apartments earning rise are also 5%. It is basically a simulation of times where cost of apartments go high, and as we can see, unfortunately our pair was not able to get any apartment, and unfortunately, since they weren't able to get any sort of passive income before retiring, they were doomed to wither. Yeah, that's grim. But now let us see something interesting, and it is quite typical for differential equations, which is a breaking point. As you can see, I've increased the earnings from multiplication of 2.0 to the multiplication of 2.1, and in such environment our pair was able to get houses quick enough, so the apartments started investing another apartments, and they will not fall into the poverty, but they will rise to the riches. It is remarkable, because it presents how important is time and these initial conditions, that they can break or make any sort of a strategy. Now let us check with what precision can we determine this make or break point. Here I've changed the initial earnings to multiplication of 2.021, and as you can see, it is still a poverty. They go into the debt, but when we increase their initial earnings by multiplying by 2.022 instead of 2.021, they make a break, and they are able to buy enough apartments to accumulate money and survive. It was such a minuscule amount changed, but differential equations have this property. In certain cases, this tiny little change can make all the difference. But right now, let us see the current Polish scenario, which is apartment inflation 10%, cost of living inflation 20%, earnings rise 2%, and apartments earning rise 30%. And our couple just dies. As you can see, the numbers are getting ridiculous. Earnings from one apartment, E12. It is the scientific notation, and it means that right now we have 2, 5 and 11 zeros. So it is thousands of billions from one apartment. Of course, this is bonkers. No system can endure such inflation for a long time, because it is simply lack of any sort of stability. But let us continue with this example. Let us see if we increase earnings from multiplication of 2.021 to 4.0. As you can see, it is still nothing. It didn't help much, but if we multiply it by 4.4, you can see that they actually survives. So all it takes is to have a pair of people in a marriage, and each of them must earn 2.2 times more than the national average. Now, of course, I'm not even going to comment on the actual numbers, because as you can see, the apartments owned are measured now in 1, 2 and 132 zeros. And accumulated money are 2 and 108 zeros of dollars. Like, those numbers are insane. It is lack of any sort of stability. So this is it. Of course, one more time, you have to take this model with a grain of salt, to say the least. It is just to present certain behaviors in the differential equations. Okay, so this is the end of this simulation. I hope it presented a bit of the differential equations. I know that there wasn't much of the mathematical formalities of the differential equations. Actually, there were differential equations, but they were solved directly by a brute force. Such simulations have its advantage that they can be done quickly. However, unfortunately, the actual mathematical operations on the equations themselves allows for better precision and for better computational time, because in order to simulate, let's say, 100 years, 100 epochs, we have to compute for 100 epochs, and in case of 1000 epochs, we would have to compute 1000 epochs. When we have the actual equation, we've solved the differential equations, we have the equation, then in both cases of 100 years and 1000 years, it is just like that. It is instant computation without need for simulating. However, it is still good to know how to do such things, because then you can program it way faster. We also learned a bit about inflation, and it seems that there's a difference between 2% and 5% inflation. In the first moments it doesn't mean much, but later it becomes quite problematic. The code I've used for simulation is under the link in the comments. Thank you for now. Please consider leaving a like, maybe even subscribe, and we see each other in another episode.